Welcome back. So today we are going to be working on our inverse trig function. So we are going to be starting on page 294 of our notes. And we're just going to be filling in a few pieces here that we still had from our trig section. And most of these, if you look on page 293, that chart will be able to help you to fill in these missing pieces. So, like I said, we're going to start out here with this chart right up here. So when we have pi over 6, that's equivalent to 30 degrees. So at 30 degrees, what is our sine? Our sine should be 1/2. Okay, and again, like I said, if you look on your page 293, you should see that you already have these filled in. So then what is cosine at 30 degrees or pi over 6 radians? Cosine is going to be our square root of 3 over 2. So then the next one, when we're looking at pi over 4, that's our 45-degree angle. So then sine is going to be square root of 2 over 2, and so is cosine. Pi over 3 radians is the same thing as 60 degrees. And so when we're looking at that one, we're going to take these 30 degrees and we're going to flip those. So sine becomes our square root of 3 over 2, and cosine becomes our 1/2. Okay. As far as this unit circle piece goes, you have all of the information to complete this from your unit circle project. So I'm actually going to leave this for you guys to be able to fill in on your own. And then just as a reminder, we have this piece up here at the top that just reminds us whenever we're finding those coordinates, the x value here, the y value is our height, and then our hypotenuse is always 1 because our radius is 1. So just a few reminder things on there for you when we're dealing with our basic trig functions and using our unit circle. All right, so today's focus is going to be on inverse functions. So that is our yellow foldable, and this is on page 302 in your notebook. So we're going to be working with sine to the -1, cosine to the -1, and tangent to the -1. So what do all of those things mean? So if we look inside here, we can see sine, if we have sine of A equals x, and we're trying to find A. Let me see if this helps a little bit, makes it a little bit better. So if we have sine of A equals x, I apologize, it's focusing there, and we want to find A, then sine to the -1 of x is going to equal the measure of angle A. Okay, and how that works, if we think about it, if we have sine of A equals, we're going to have our opposite, which is BC, over our hypotenuse, which is AB. Okay, if I want to find A, I'm going to have to divide by sine on both sides. Now my calculator is not going to let me do that because it always wants something at the end. So the reason why we use the -1 is because if you remember back to your exponent rules, the -1 tells me I'm going to move either from numerator to denominator or denominator to numerator. You're just switching it from wherever it's currently at. So A equals, if I want this to move to the top, I'm going to go sine to the -1. That moves it to the top. And then this is going to be BC over AB. Okay? And that's actually what I have written here for you guys. So it's the same thing for cosine and for tangent. So what I want to show you next is where that's at on your calculator. So if you look on your calculator, you'll see your sine, cosine, and tangent. Then if you notice in a different color up above, you'll see sine to the -1, cosine to the -1, and tangent to the -1. So on my calculator, I hit the second button because these letters are in yellow. So I hit second, and then my sine button, and then it will actually come up with sine to the -1 up here on my calculator. Okay? All right, so that's how we get to those on our calculator. So now we're going to do some different examples. So over here on our examples, we're going to start with sine. So we're going to be looking at this information over here. So if we have sine of b equals 0.87, if we want to find b, we're going to take sine to the -1 of whatever is here. And that's going to equal b. So then on our calculators, we're going to type in sine to the -1, and then I have parentheses 0.87 in my parentheses and hit enter. Okay, so for this one it comes up with 60.45 something something something. I'm going to round to the nearest degree for today. So B is approximately 60 degrees. Okay. So for the next one, now we have it written as a ratio. So we're going to take sine to the -1 of whatever is here. So that's going to be 12 over 13 equals A. So again, on our calculator, we're going to type in second sine, so we get sine to the -1, and then parentheses 12 divided by 13, end my parentheses, and then hit enter. And I end up with 67 degrees approximately. Now, A and B are not in the same triangle. Okay, if they were, then they would be complements, and I'll show you that here in just a few minutes. But for these, they're not the same triangle, so we're just doing these completely independently. All right, so moving over to our cosine. So same thing, we're going to start out with the decimal one. So we're going to take cosine to the -1 of whatever that is, and that's going to give us our angle. So for this one, we have cosine to the -1 of 0.15 equals C. So on my calculator, I'm going to type in second cosine, so I get cosine to the -1, parentheses 0.15, end my parentheses, and hit enter. And for that one, I get 81 degrees approximately. Okay, let's try the next one. So we have cosine of B equals 91 over 109. So I'm going to go cosine to the -1, 91 over 109 equals B. So on my calculator, second cosine to the -1, parentheses 91 divided by 109 in my parentheses, hit enter. For this one, I get approximately 33 degrees. Okay, last type is with tangent or inverse tangent. So we have tangent of A equals 0.75. So to find A, I'm going to go tangent to the -1 of whatever's here. So 0.75 equals A. So on my calculator, second tangent, so I get tangent to the -1, parentheses 0.75, in my parentheses, hit enter, and I'm getting 37 degrees, approximately. All right, last one is a ratio. So we have tangent of C is 5 over 12, so we're going to go tangent -1 of 5 over 12, because that's what's here, equals C, because I want to know the measure of angle C. So calculator, second tangent, so we get to the -1, parentheses, 5 divided by 12, end my parentheses, and I get 23 degrees approximately. Okay, great job with that. Let's do some more practice. So these are some different types. So on the center here, we have our practice. We're going to determine which angle has the given trigonometric ratio. So looking at this picture over here, sine of the angle is 12 over 13. So remember, sine is going to be opposite over hypotenuse. So that means 12 has to be the opposite. 12 is opposite of what angle? That's angle E. So this is angle E. Okay. Next one, tangent of the angle is 5 over 12. Tangent is opposite over adjacent. So again, my opposite has to be the 5. So opposite of 5 is F. So this is angle F. Okay, we're not figuring out any angle measurements. We're just figuring out which angle has that ratio. All right. Next section, now we're going to use a calculator to approximate the measure of angle G, angle H, and angle K to the nearest tenth of a degree. So nearest tenth of a degree is what we want to go to this time. Okay, so it says tangent of G equals 0.43. Well, that's like the one that we did over here, tangent of A. So I'm going to do tangent to the -1 of 0.43 equals G. Okay, so on my calculator, scoot this back over. So I want tangent to the -1, parentheses 0.43, end my parentheses and hit enter. And it says we're going to the nearest tenth, so I get 23.3. So the measure of angle G is approximately 23.3 degrees. All right, for the next one, we're doing sine of H. So that's like the ones that we did up here. So we're going to take sine to the -1 of 0.68 equals H. So on my calculator, second sine, so I get sine to the -1, parentheses 0.68, in my parentheses, and hit enter. Rounding to the nearest tenth, I get 42.8. So the measure of angle H is approximately 42.8 degrees. Last one is cosine, so that's like these that we did here. So I have cosine to the -1 of 0.94 equals K. So on my calculator, second cosine, so I get to the -1, parentheses 0.94, in my parentheses and hit enter, and I get 19.9. So the measure of angle K is approximately 19.9 degrees. Okay, great job with those. So the next type that we have, now we are going to solve the right triangle. So when we're solving the right triangle, that means we're going to find all of the sides and all of the angles. Well, we already know these two sides, so we need DE. We know angle F, but we don't know angle D or angle E, so we're going to do angle D and angle E. So we need to find all three of those pieces. So I'm going to start out with DE. So you can do this a couple different ways. If you have your angle measurements here, you can use a trig function to find your missing side. But I don't have any of those angles, so I'm actually going to start out with my Pythagorean theorem because I know my other two sides. So I'm going to take a squared plus b squared, so 20 squared plus 21 squared equals my hypotenuse, which is DE squared. Okay? So my next step, I'm going to square these. I get 400 plus 441 equals DE squared. So I get 841 equals DE squared. So now I have to take the square root of both sides. So the square root of 841, I get 29. So 29 equals DE. So I'm going to put that up here. And that was an exact answer. I didn't round, so I put equals. For D, I'm going to be working with the two legs. So that means it's going to be tangent. So tangent to the -1 of my ratio. So tangent is going to be opposite over adjacent. So 21 over 20 equals D. So plugging that into my calculator. Second tangent, 21 over 20. And I get approximately 46. So 46 degrees approximately. So over here, approximately 46 degrees. I'm going to put measure in front of each of those. So then for E, I'm going to do the same thing, but this time my ratio is going to be 20 over 21. So tangent to the negative 1 of 20 over 21 equals E. So again, on my calculator, tangent to the negative 1, and we said 20 over 21. Oh, I forgot my parentheses. Make sure you put those in there. 20 over 21 in my parentheses, and I get 44 approximately. Now, these are on the same triangle, so you'll notice 46 and 44, those add up to 90, and these are supposed to be complementary, so this is my self-check to be able to make sure that my answers are reasonable. Now, you'll notice I didn't just, when I had the 46, say, okay, well, 90 minus 46 is 44. I actually used my trig function, and like I said, the reason for that is because that's my check to know that I did my math correctly. So if those come out and they're complementary, then I know that I'm okay. We have one more of these to do. So down here, they gave us GH, they gave us JH. We need to find GJ. So GJ. We know angle J, we need to find H and G, the measure of angle H and the measure of angle G. Okay, so again, I'm going to start out here with finding my other side. So this time I have one leg and the hypotenuse, so I have 91 squared plus b squared equals 109 squared. So typing those into my calculator, 91 squared is going to give me 8,281 plus b squared equals 109 squared, which is 11,881. So I'm going to subtract so I can get b squared by itself, and that's 3,600. Take the square root of both sides, and then I get 60. So b equals 60, and that's an exact, that's not an approximation. So b was the same thing as my GH, so this is 60 units long. Now for H and G, for H, since I have the adjacent and the hypotenuse, I'm going to use cosine. Cosine of H equals 91 over 109, so then I can say cosine to the negative 1 of 91 over 109 is going to equal H. So typing that into my calculator, making sure we use parentheses, I'm getting approximately 33. For G, we have the opposite and the hypotenuse, so I'm going to use sine. Sine to the negative 1 of 91 over 109 equals G. So sine to the negative 1, parentheses, 91 divided by 109 equals approximately 57. So then 57 and 33, that adds up to 90. So I know that my answers are correct there because they add up to be complementary angles. That is all that I have for you today. Again, this is for 9.6. We're solving right triangles using our inverse functions. Have a great day, and I will see you in class.